factor. For example, look at number 6. Do you notice something particular? Now, we learned this whole way. We went through, we factored it. We got this answer, right? And we did the whole process. What multiplies to be A times C and adds up to be B. What do you notice about some things between this and this? I just heard you talking in your groups about it, so tell me.
The factors you choose are in the answer.
Wait, say that louder.
The factors like you choose are in the answer. 1 times 6, you have 1 and 6.
Oh, so you're seeing an interesting relationship. You're saying this factor and these are the factors you chose, and interesting enough, that's looking like the answer. Okay, so was that true for the whole front page? I want everybody to look at your whole front page and tell me yes or no.
Yes.
Take a look for a second. Look at those. So look at number 1. Did something interesting happen on that same one? The same interesting thing here? So we said our factors were -9 and -2, and interesting enough, our answers had a -9 and -2. Cool. All right, and number 2, you got 10 and 4 were your factors you chose, and then interesting enough, and your answer was 10 and 4. So, awesome, you're absolutely right. Now I want you to flip to the back page. Now look, does that same thing happen? Everybody think for a second. Don't answer out loud, just think. On the back page, did the same thing happen? The 2 factors were those simply your answers? No. Okay, what's the difference between the problems on the front page and the back page? Figure it out. Ready, set, go. I'm going to ask again. Okay, so what is the difference between the front page and the back page, guys? Yeah.
You only have 1 A value.
So you're saying A was 1 on the front page, the whole front page, and then on the back page, the whole A value wasn't 1. Okay, very good. So hopefully you guys are seeing a connection here. Okay, so now today we've learned how to long factor. I mean, it's my own thing, I call it long factor. We learned that for a reason, because there are times when you cannot quick factor. Today we're learning a little thing, and hopefully you're already seeing it. Today we're going to learn something called quick factoring, but you're already seeing it. It's the whole front page. So, we can only quick factor when A is equal to 1. Now, the reason we have to learn long factoring is because we cannot always quick factor. In fact, I'm going to make you take a vow in a minute that you won't quick factor when you can't, or else you'll get the answer wrong. So, everybody understand, if your A value is 1, you can quick factor, and you'll know that whatever multiplies to be A times C and adds up to be B, those will be your answer. Those will be your 2 factors. So, aren't we going to factor much quicker now? A lot of them? Yes. Do we still have to be able to do the long way factoring? Yes, because a lot of problems are not going to be able to be quick factored. So I want you to look with me, really quick, everybody. Can we quick factor this one?
Yes.
Yes, so let's do it then. What multiplies to be? A times C, so it multiplies to be 40 and adds up to be 14. 4 and 10, right? And they were both positive?
Yes.
So we know now, since A was equal to 1, it's going to factor to be a binomial with x, and it was positive 4, and x with positive 10. And we're done. Way quicker, right? Okay. Could we quick factor this one? No. If you did, you'd get it wrong. You can't quick factor. So that's why we learned the long way yesterday, because really, you have to be able to long factor the rest of the year. Can we quick factor this one?
Yes.
Yes, because our A value is 1.
1.
So we're looking for what multiplies to be A times C. So what multiplies to be -49 and adds up to be B? Well, B is 0. So 7 times 7, and one of them has to be negative. We know we can quick factor because A is 1. So it's simply going to factor to be a binomial with those 2 things. M minus 7, due to that -7, and that's positive 7, so M plus 7. Very quick. Awesome. Okay, so now we're going to take a little vow as a student that we will not quick factor unless we can. Because that's why I don't just teach you that yesterday. I don't say, hey, if you have these kind of problems, just quick factor. Because then students don't learn how to long factor. And you have to long factor if A is not equal to positive 1. So we're going to all say this. 3, we're all going to say it. Ready? Say your own name. 1, 2, 3. I promise to never use quick factoring unless I am able to do so. I understand that I can only use quick factor if A is equal to 1. Otherwise, I will long factor so that I can get the correct answer. Okay, you've all taken the vow. You've all sworn. So if you quick factor in the future, I get to psh, psh. Okay? All right. So let's go through number 1 on today's worksheet. Here we go. Can I quick factor? That's the first thing you're going to ask yourselves from here on out. Yes. And is there anything in common in the beginning we can pull out? No. Okay. So we do what multiplies to be A times C and adds up to be B. Now this is still quick factoring. So we're doing what multiplies to be 1 times 30, what multiplies to be 30, and adds up to be 11. What are the two factors? 5 times 6. Are they both positive?
Yes.
Yes. And we can quick factor because A was equal to 1. So it's simply going to be, so that was positive 5 and positive 6. So it's going to factor to be K plus 5, because it was positive 5, times K plus 6, because it was positive 6. Now, on the first part of the worksheet, they gave you part of the answers just to see if, to kind of give you a hint if you've done it correctly. Everybody good with that? Pretty easy, right? So much quicker, right? Okay, now, number 2, let's do it quick. Can we quick factor?
Yes.
Yes, because A is 1. What multiplies to be 1 times 9, which is 9, and adds up to be 6. 3 times what? 3 times 3. So we know this factors to be x plus 3 times x plus 3. Very good. Questions? Okay. So, everybody, look up here. Don't go ahead, or we're not going to earn it. I want these 2 people on your table to do problem number 3, these 2 people to do problem 4. We're going to swap answers.
Those 3.
Okay, now these people in your diagonals do 5. These people do 6. Ready, set, go.
Aww.
7 through 29. On your own. 7 through 29. Ready, set, go. Okay. So we're asked to find question mark. Now yours might be in words. If you need to draw a picture, draw a picture. But it's all the same thing. So let's think about it. We're given this picture. We're given the area is equal to x squared plus 5x minus 6. And we're given this length, this x minus 1. We're asked to find question mark. So I'm going to just set up the statement right now just to see what I'm looking at. So I know in general area of a square or rectangle is length times the width, right? Everybody?
Yes.
So then our area is this, x squared plus 5x minus 6. And that's equal to our length, which is x minus 1, times by our width. So times, I'm going to change the color, times by width. Now let's think about this. We know if we took this width and we multiplied it in, wouldn't that put us back here? Isn't factoring the exact opposite of multiplication?
Yeah.
Yes. So if we peeled this piece apart, wouldn't we have the 2 factors that multiply to be that? So wouldn't that make sense to factor it so that we know what the width is? Yeah? So let's factor it. Let's factor it. So let's do what multiplies to be negative 6 and adds up to be 5. 1 times 6, 3 times 5. Let's make sure we pick the correct one, because look, 1 and 6 technically could add up to be 5. 3 and 2 technically could add up to be 5. But it's got to work in both squares. So will it be 3 and 2? No, because they both have to be positive, and that's not negative 6. Okay, we do need this one. We'll put the negative with our 1 so that it adds up to be positive 5. Can I quick factor this? Yes, A is equal to 1. So it's going to factor to be x minus 1 times x plus 6. All right, so what do you think the width is? If this is the factored piece of the area, isn't this the length, guys? So what's the width?
X plus 6.
Very good. So our width is equal to x plus 6. You're awesome. Is everybody good with those problems? Not hard, right? Not too bad. Okay, so I want you to do these problems, 42, 43, and 51. Skip to those. These are required problems. We're going to be kind of skipping around. Just stay with me today so that we can all learn the free 10 paths. Here we go. I'm going to do problem number 1. Factor. That's all we're going to say. It's not going to say quick factor or long factor. It's going to say factor. You have to be the one to use your brain and choose, can I quick factor or must I long factor? Number 1, 2w squared plus 13w plus 15. I'm looking at number 1 on your second page. There is not room. You're going to need a scratch piece of paper. There is nothing worse than having it squished and getting it wrong. I have to do a scratch piece of paper too. Okay, so, can I quick factor this? No, why not? Okay, good. I like what Justin said. He said because there's not a 1 in front of w squared. You're absolutely right, Justin. All right, let's go through this. So we're going to not quick factor, we're going to long factor. So A is equal to 2, B is equal to 13, and C is equal to 15. We're doing what multiplies to be A times C, what multiplies to be 30, and adds up to be 13. Tell me the factors right off. 10 times 3, and they're both positive. Now, because we cannot long factor, we're now to the step called drop and break. I'm just going to erase this to give myself some room here. Drop and break. Drop down our end terms, drop, so 2w squared plus 15, and break down your middle term. You're rewriting 13w as 10w plus 3w, because this is technically 13w. We're rewriting it. Order doesn't matter. So plus 10w plus 3w's. Then we put parentheses around the first 2 terms. We put parentheses, including the sign, around the second 2 terms. And then we're going to look at each group and factor out the greatest thing in common. So in this first group, there's a 2 and a w in common, right, everybody? So I factor it out. Now, once you factor it out, you have to write on the outside of your parentheses. Go back through, divide each term by what you factored out to see what's left. 2w squared divided by 2w is w. 10w divided by 2w is positive 5. Do we have questions? In this one, we're pulling out a positive 3 in parentheses. Now notice I wrote what I pulled out. A lot of you forget to do that. Divide each thing by what you pulled out. So we have w because 3w divided by 3 is w. 15 divided by 3 is plus 5. Check your safe haven. Safe haven, yes, we've done this correctly because that's exactly the same. If not, look back and see what you've done wrong. Either your factors are not right or you factored wrong here. So we pull that w plus 5 out. Now when we pull it out, we write it on the outside. And technically what we do when we go back through is divide it out of each term. Because to pull it out, we divided it out. Left was a 2w plus 3. And we have factored this. We truly could not have quick factored. In fact, let's look. If we would have quick factored, we would have got, we would have had w plus 10 times w plus 3. And that is not our answer, right? So do you all understand? We really would not have gotten it right if we quick factored. Okay? If we could have, if we could do it any easier, I'd give it to you. This is the way. Okay. Another one. Nope, never mind. We're going to work in groups. So these 2 people on the front are going to do number 2. The 2 people on the back are going to do number 3. Show your work so that you can show each other how you did it. Ready, set, go. Together. Guys, you need to watch a little bit more carefully, I'm pretty sure, this time. Yeah.
Number 2 together.
Nope. Number 6. Here we go. We're going through it. Everybody needs to pay close attention because you've got to be able to factor, guys. 6g squared minus 2g minus 20. Now, I could do this a couple different ways. I'm still debating, honestly, but let's just go ahead and go for it. Number 6. Let me see if I wrote that down. Nope, I didn't. Which problem is that? What in the heck?
It's 14.
14.
That's number 14?
Yeah.
Okay, I'm going to change this to number 14. Sorry, not number 6. I was going to say, I'm looking at number 6, and then I'm like, what? Okay, number 14. That's the one I'm going to do. So we're doing what multiplies to be A times C and adds up to be B. Okay, let's go for it. So 6 times negative 20. Now, I still am debating on which one I should go for. Let's actually go this way. Let's get practicing with this. What's in common in the very beginning? What do they all divide by? 2. So I'm going to factor out a 2 in the beginning on this one. Okay, so when I factor out a 2 in the beginning, I divide each thing by 2. And let's see what we get here. 6g squared divided by 2 is 3g, right? And then negative 2g divided by 2 is negative g. Is everybody following what I'm doing? Just 6, 2, and 20 all divide by 2.
Yeah.
So I'm pulling out a 2. Go back and divide each thing by what you pulled out. 6g squared divided by 2 is 3g squared. I'm writing what's left, right? This is what we do in factoring, guys. And then we have negative 2g's divided by 2 is negative g. Negative 20 divided by 2 is negative 10. Now let's look. In here is a quadratic. Yes or no?
Yes.
Yes, because it's degree 2. So we need to keep factoring this. So we're going to ignore this 2 for a minute. And we're going to keep factoring this piece. So we're doing what multiplies to be a times c. Now Riley, you've got to do a times c. Does that make sense? We're looking for what multiplies to be negative 30 and adds up to be negative 1. So 5 times 6, right? One of them would have to be negative. Which one? 6. Good. So then we know our factors are positive 5 and negative 6. Now we have to drop and break. So I've got to give myself some room. You drop down your n terms. So we're dropping down 3g squared. We're dropping down negative 10. And then we break down our middle term. We're rewriting it as those two factors, but as a g. So it'll be positive 5g and minus 6g. It actually would have been an easier factor if I would have put the minus 6g first and the plus 5g over there. But it's okay. Remember, order doesn't matter. Throw parentheses around the first 2. Throw parentheses around the second 2. Factor each group. What's in common in group 1? G. So what's left is 3g plus 5. Are you guys following me still? Okay. Factoring out a negative something, but negative what? Factoring out a negative 2. Divide each thing by negative 2. So negative 6g divided by negative 2 is positive 3g. Negative 10 divided by negative 2 is plus 5. Check your safe haven. Safe haven, it's the same. So factor it out. 3g plus 5. And then g minus 2 is left, right? Now don't forget, in the beginning we had a 2 factored out, right? So we got to put that 2 with our answer. That is factored completely now. There was only one extra step. There was something in the beginning, right? That's literally the only extra step. I pulled it out and didn't forget to write it in my answer here. Okay, so just make sure your things are factored completely. Now, guys, if you wouldn't have factored out the 2, it would have been okay. We would have just had bigger numbers, right? We would have factored. And then what would have happened is you would have had some linear factors. Like, for example, let me show you so that this makes sense to you. If you had 4g minus 2, let's say this is our answer, and g plus 3. Look at our linear factors. Doesn't this one factor further? Couldn't we pull out a 2? So we pull out a 2, and left was g minus 1. So g plus 3. Does that make sense? This is just factoring it completely. Does that make sense? So if you would have done it this way, that would have been fine. You would have just ended up with something that could factor even further. This would have been 6g plus 10 if you would have done it the long way. Does that make sense? And then you could factor out one more thing. Okay?
It'd be easier to do it the first times.
I think it's easier to do it at the first because then I have way smaller numbers in here. Does that make sense? So that's why I always look, is there something in common? And a lot of times what will happen, you'll factor it out and it will make this part quick factoring. So then it's way quick. You know what I mean? So that's why I always factor it out first. But really, it's your choice. It's really your choice. But that's what, like I said, a lot of times when you pull it out in the beginning, it makes it quick factoring on the inside. So then it's way quick. Okay. I'm going to have you do 1 through 19 on the second page. And then Let's for now skip 17, 8, okay. I'm going to change this. 1 through 15. That is absolutely required of you. 1 through 15 on that second page. I'm going to let you work. I might bring you back to me to do 16, 17, 18, and 19. Ready, set, go. Or we might finish it up tomorrow. We'll see. This is such a good one. On number 3, everybody look. This is really important. 2n minus 1. How many got this answer? Times 2n plus 32. How many got that answer? Raise your hand. Okay, awesome. Yours is correct. Now also, we have this answer, which is also correct. Equally correct. I'm going to show you why. Raquel, she asked me, is my answer right? And I told her no. And now it's aha-ing me that, yeah, she's just as right as I am. She just factored differently. So Raquel, what was your answer?
N plus 16.
N plus 16.
And 4n minus 2.
4n minus 2. Okay, so this is a good point of why we need to factor completely. Guess what? Those look tremendously different, don't they? They're both equally correctly. It's just equally, they're not simplified all the way. They're not factored all the way. Let's look at this piece. Can this piece factor more? No. But could this piece factor more? Yeah, so let's pull out a 2, and left is n plus 16, right? Everybody? So factor completely would be that times that, which is 2n minus 1. Now let's look at this answer. This piece is factored completely, but is this piece? No, what would we pull out? 2, and left is n minus 1. So writing that multiplied would be also times n plus 16. Now we'll look at our final answers. Don't they match up perfectly? Look at our final answers.
Yeah.
Aren't they the exact same?
How did they get that one though?
Because she switched the b values.
4 can divide by, well, yeah, 16.
She just, yeah. So it came out differently. So when I initially looked at hers, I'm like, no, not right. But then it hit me. Oh, yeah. This is a good example of why we factor completely, because hers was just as right as mine. We both just weren't simplified all the way. We were factored all the way. So just make sure you look back at all your answers and make sure that they're factored completely. So good job, Raquel. I'm really glad that that happened. This is how we learn, is making mistakes on my part. So you were incorrect. Very good. Awesome. Okay, good one. Continue.